terms of equations so far, and we're actually going to get into that using matrices. But the first thing first, we got to figure out what a matrix is right away before we can actually solve a system using one of our matrices. So first of all, a matrix, we got to figure out what it is. It's a rectangular arrangement of numbers in rows and columns, which are enclosed in brackets. Okay, and each number is called an element. So if I look here at my matrix, right, I got a left bracket and a right bracket, and there's 2 rows and 3 columns, it looks like, right, because rows go side to side. So this would be row 1, this would be row 2, and then columns go up and down. So this is column 1, column 2, column 3. So it looks like I have 2 rows, 3 columns, and each number in there is an element. So for example, 7, that's an element. It's located in row 1, column 2. Okay, pretty straightforward, right? And when we state the dimensions of our matrix, or the dimension of my matrix, I always put the rows first. We're going to say the rows by the columns. Like, you know what dimensions are, like the dimensions of the room. It's the length by the width, right? So like 10 feet by 8 feet. So if I were to write the dimensions of this matrix, well, it's 2 rows. So I'd put 2 by, and we use the letter X for by. I'd say 2 by, and it's got what, 3 columns up here? 3 columns. So it's a 2 by 3 matrix. This would be a 2 by 3 matrix. So let's use that information. We're going to state the dimension of the matrix. Let's do that for number 1. Let's state the dimension. Well, there's 2 rows, 1, 2, 2 columns, 1, 2. So I say it's a 2 by 2 matrix. Okay, then identify the position of the circled element in each matrix. Well, if I look, this number 4 is circled, right? It's in the first row, right? And in the second column. So that's all I would say. First row, or row 1, and second column, or column 2. That's all there is to it. Same thing with number 2. Right? State the dimensions. So I would state the rows first. So I got 1 row, 2 rows, 3 rows. That's supposed to be an R. So it's a 3 by what? 1, 2, 3, 4, 5. It's a 3 by 5. 3 by 5 matrix. And -3, that element is located where? Well, it's located in row 3, column 4. Column 4. Okay, not too difficult. So stating the dimensions and telling where an element is located. Get a little bit trickier. It says find each sum. I meant to put or difference here. Or difference. Find each sum or difference. If the matrix does not exist, write impossible. So I have 3 matrices here. I got A, B, and C. And number 1 tells me I want to take A minus B. So I'm just taking A. I'm going to rewrite A. So I got -8, 4, 15, -3, and 9, 7. And I'm subtracting B, which is -12, -8, 10, 11, and -13, -6. Well, to subtract these, what kind of matrix do you think I'm going to end up with in the end? What dimensions? These are both 2 by 3s, aren't they? So that's exactly what I'm going to end up with. I'm going to end up with a 2 by 3 in the end. Well, it's A minus B. So all I do is I just take the element subtracted by the element in the exact location. So I would take -8 minus, right, I got the minus sign, -12, because they're both in row 1, column 1. So -8 minus -12, that's what I'm doing right here, which -8 is really plus +12, which gives me a +4. So that's a +4. So I just add the element, or I'm subtracting in this case. So I just go by which spot it's in. So then I look at the next column over. So row 1, column 2. So 15 minus 10. 15 minus 10 is 5. And then 9 minus -13. Minus the negative is really adding a positive. So 9 plus 13, which is 22. And I do the same thing with row 2. So I go 4 minus -8. So 4 plus 8, which is 12. And then we got -3 minus 11, or negative 3 plus negative 11, which is negative 14. And lastly, 7 minus negative 6, and 7 minus negative 6 is really 7 plus 6, so 13. So here would be those two matrices subtracted by each other. So I just subtract each element in whichever location they're located. Kind of makes sense, doesn't it? How about this? I want to try to add A plus C. Well, if you notice, A is a 2 by 3, and C over here is a 1 by 3. There are two different types of matrices. So do you think I could add those together? Nope, can't add them together. So I would state that this is impossible. Impossible. They have to be the exact same dimensions in order to add or subtract them. Yeah, they have to be the same dimensions. And if they are, just do it element by element. Okay, we could also do something called scalar multiplication. Scalar multiplication. So in this case, I'm taking 5 times this whole matrix. 5 times this whole matrix. Well, what do you think? My new matrix, when I multiply, should be the same size. So I have a 1, 2, 3, 4 by 3. I got a 4 by 3, so I'll probably have a 4 by 3. Or I should. I'm not probably. I'm going to have a 4 by 3. Well, don't think too hard. But what do you think is going to happen? Well, I just take 5 is right next to this matrix. That means this is times, isn't it? If there's no operation in between there, it's right next to it. So I just take 5 times each element. So 5 times 2. So 5 times 2 is 10. Then I take 5 times 1, 5. 5 times 7, 35. And so on and so forth. So 5 times 8, 40. And then I go to the second column. 5 times negative 1, negative 5. 5 times negative 3, negative 15. 5 times 10 is 50. 5 times negative 9 is negative 45. Yeah, I think you get the idea. 5 times 0 is 0. 5 times 5 is 25. 5 times negative 11 is negative 55. And 5 times negative 4 is negative 20. Okay, so the basic parts to our matrices make sense, right? If I add or subtract matrices, they have to have the same dimensions. Each element is located by a row or a column. Those types of things, okay? It all kind of makes sense when you start to think about it. So that's really all there is for our introduction into matrices.